Assalamualaikum warahmatullahi wabarakatuh. Let's continue on the next subtopic of hydrostatic fluid pressure 2.1.6, which is hydrostatic paradox. Okay, what is actually the hydrostatic paradox? This is the hydrostatic pressure on horizontal plane where the pressure is still the same. Okay, because it is not influenced by the weight of fluid. Okay, so we can see here even the shape of the container is different, but the area is still the same. Okay, base area is still the same, so the pressure is same for all beaker, for all container. Okay, two factors that influence hydrostatic paradox, it is the base area and another one is the vertical head. Okay, I already mentioned previously where the head must be calculated via vertical height. Okay, so the head must be calculated via vertical height even though it is inclined. Okay, we still consider the head is on vertical height. Okay, then pressure measurement. Okay, we have various means and device to calculate pressure, which is barometer. Okay, already discussed previously, to determine atmospheric pressure, piezometer, and lastly is manometer. Okay, let's go through one by one. Okay, we have here barometer. It looks like inverted test tube. Okay, barometer is to measure atmospheric pressure or PATM. Okay, we can see here where is the atmospheric pressure. It is at B. Okay, B is atmospheric pressure. Point A is vacuum pressure because here we have gases. And then how we calculate pressure in the barometer? It is pressure at A plus pressure B, rho GH. So here we are using density of mercury and then we get atmospheric pressure. Okay, so for pressure A, the pressure is relatively low because of the vacuum conditions, or maybe it can be taken as 0. So we don't count the pressure at A. So the formula of atmospheric pressure is rho GH. Okay, next device is piezometer. This is how piezometer looks like. One end is connected to the point or pipe. So we put point A in pipe. And then one end is open to the atmosphere. Okay, how we measure pressure using piezometer? It is based on rise of liquid at point A. So rise of liquid H1 is the reading for pressure using piezometer. Okay, then we have U-tube manometer. It is consists of glass tube bent in U shape. One end is connected to a point B. You can see here point B. And another end is also remains open to atmosphere. Okay, the tube is normally contain mercury or other liquid. Now, what is other liquids? Other types of oil. Maybe glycerin, other type of oils. And then also water. Okay, so the different shapes, different color is considered different types of liquid, different density. Okay, so we have two types here for gauge pressure and for vacuum pressure. Okay, for gauge pressure, we don't have the vacuum condition like the B. Okay, here is the vacuum conditions. So there is a difference. Another one is the datum. So here we don't have pressure at the right angle, at the right side. Okay, for U-tube manometer, basically we divided into left. So we have here left limb. We call it left limb, or this one right side. Okay, so for vacuum pressure, there is no right, no pressure at right. So pressure at right is 0. Pressure of right limb is 0 for vacuum. Okay, then U-tube manometer that measure gauge pressure. So same goes here. In the left column or left limb, we have pressure at B. This is pressure at B plus the pressure here at H1. So we use density for left column, and then G is 9.81, H is H1. This is for the left column. And for the right column, this one, we have pressure, we have density 2 times gravity and times height 2. And then we need to equating both pressure. So we get this one, pressure at point 2 minus pressure at point 1, and we get the pressure for B, pressure at point B. Okay, and then U-tube manometer for vacuum pressure. Okay, here is the difference, the 0. Okay, the pressure for left column, we have pressure at point B, and then we have for H1, and then we have pressure for different liquid, H2. So density 1 and density 2 is different, maybe oil and mercury. And then for the right column, you can see here it is 0. Because the point A for the right column, it is at datum. Lowest point in the pressure, so we call it datum. Datum is 0. So for vacuum pressure, we get negative pressure for H2 plus the pressure for H1. For liquid, for another types of liquid. Okay, let's go through the examples. So we have simple U-tube manometer. Inside is mercury. We have mercury, and then specific gravity 0.9. This one basically is an oil. Okay, the center of the pipe we have 12 cm. So maybe H1 and another one is 20. Okay, then so we have given here, we have SG, specific gravity, need to convert to density with times 1000. So this is density for oil here, the dotted red for oil. And then we have 13.6 specific gravity. This is basically mercury. So for density at 2. And then we need to minus 20 with 12 to get the length here. So we get here 8 cm. So both high need to convert to meter. So we have H2 0.2 and H1 0.08. Okay, so actually we are measuring here 0.08. Okay, this is datum line. This is datum line. So actually the flow is from here to here. Okay, we are not counting the below the datum. Okay, so it's from here to here. Okay, so then we substitute into the equations. So we have pressure at point here plus the density 1, gravity 1, H1. So H1 is 0.08. Then equals to another side, right limb. So using mercury as the density and the H is 0.2. So we get the pressure of 25977 Newton per meter square, or you also can write as Pascal for pressure. Okay. Okay, next examples. This is for vacuum U-tube manometer. We have a specific gravity of 0.8, and then the end is open to atmosphere. Find the difference of mercury levels at two limb is 40 and the high is 15 cm. So we have 40 and 15. Okay, so you can see here for the right limb or right column it is 0. So we have density 2 times gravity times H2. H2 is 0.4 here. Cm convert to meter. So we have here 0.4. This is for mercury. And then for oil, the density is 800. And the high is 15 cm. Converting it to meter is 0.15. And then, okay, so next is U-tube differential manometer. Okay, so you can see here the pipes is different levels and we have different liquid density. So point A and point B different levels. So same method that we can use. We settle for left limb and also right limb. So for left limb we have pressure at point A, and then we have pressure for density 1. Density 1, the H is from here to here, from point A to the datum. Okay, so the H is X plus H. X plus H. And then for the right limb, we have two types of density for Y and H. So we have mercury density, the H is H. And then another density, density 2, the high is Y. And then plus the density at point B. Okay, then we equating both pressure for right limb and left limb. We bring the PB to the left side, so PA minus PB. That's why we call it as differential manometer. We need to find the difference of pressure at point A and point B. So mercury, density of mercury, pressure for mercury, plus the pressure for liquid, density 2, and then minus the density 1, H plus X. Okay, when we solve this simple mathematics, you can get the GH, density Hg minus density 1. and then plus density 2gy minus gx. Okay, next, this is same differential manometer. What is the difference is the pipe is at same levels and same liquid density. Just now we are doing different levels and different liquid density. Okay, same method, left limb and also right limb. So for left limb is pressure at point A plus the density of liquid in tube A. So the height is H plus X. And then for right limb, we have two types of density also. We have X and H. So this one is for mercury. This one is density at 2 for X and H. And then we equating both pressure. We bring PB to the left side. So the difference is PA minus PB. Simple mathematicals, you can cancel Y. And then you get density Hg minus density 1. Okay, this one salah sikit So this is X, this is not Y. We don't have Y here. So this is still X, this is X. Okay. Why you get only density 1? Because we can cancel here for X. Simple mathematics. You can try cancel and you get simplify as GH. Gravity times height times density mercury minus density 1. Okay, let's go through the examples. This is for same levels of differential manometer. B and A at the same levels. Pascal said that if it is same levels, means the pressure is same. And then we have the density, the specific gravity given 0.9. Mean the density is 900 times 1000. And then the difference in mercury levels is 15 cm. Okay, then we need to find the pressure at the point. So we have height X and H. So we settle for the left limb. Left limb, we have Px is equals to pressure at A plus 900 is the density from the specific gravity times 9.18 times the height is X plus H. Okay, it's here. This is for left limb. H plus X. This is the datum. And then for left limb, we have two different liquid. Here, this is for oil, this is for mercury. Then simple mathematics, you get Px is Pb plus 8829X and also H. And then we substitute this Px into this one, or we combine the equations. So we have 2 Px from left and Px from right. We combine the equation. So we can get the difference of PA and PB is 18.688 kilopascals. This is the different height given in question. It is in cm. 15 cm. You convert into meter, it is 0.15. Okay, because the question given the difference of mercury height. This one. Difference in mercury level 15 cm. Okay, then this one is differential manometer at different level. You have specific gravity 1.5, and at point B, the specific gravity is 0.9. And we need to find the H. We don't know the H. Find the levels in a difference in mercury level. Okay, given the pressure at A is 9.81 pascals and pressure at B is this one. So we can substitute the pressure into the equation. Okay, just ignore this because this is just the conversions of units, because the questions is directly given in meter, but this one they show that the questions is in kilogram force. This is kilogram force. Okay, so we go through the method of left limb. Okay, left limb we have mercury, and the left limb is H. The height is H. So we go back to the picture. So for the left limb we have two liquid. We have H here, another one we have oil. Maybe oil with specific gravity of 1.5 is 3 plus 2, so 5 meter, and the H. So you can see from the equation, substitute the H. So we have H and another one is 5. Okay, then PA is given in question. Just substitute the value for PA. And then we go for right limb. Right limb. Go back to the picture. How many liquid we have for right limb? Right limb we have only one, which is here. Here the height is 2 plus H. So we need to use the height is 2 plus H for right limb. Okay, so here the H is 2 plus H or H plus 2, and then just substitute the value for PB. Okay, then we equating the two pressure at left and right, and we can get this one for that. Then we dividing by 1000 times 9.81. We get this one. Why we do this? We need to simplify these equations. And then this is the simplify to find the H. So the H is 0.181 meter, or in cm it is 18.1. Okay, for this one, actually ada error sikit kat PB. So the question given that the PB is different from this value. So it's okay, you just use this value and change at the question. So this one is 1.8 times 10 to the power of 4. Okay, this one we change to 1.8 times 10 to the power of 4 times 9.81. Okay. Same goes here. We are not giving this for PA and PB. So this one you can just ignore.